Alright, in this in this video we'll be talking about the leading coefficient test to help us graph polynomial functions. So one way to improve our graphing is with the following remark. A polynomial function's degree, which is even or odd, right, and its leading coefficient, positive or negative, determine whether the graph of the function eventually rises or falls. This is called the leading coefficient test. In particular, diving a bit more into this, we have for a polynomial f of x equal a n x to the n all the way down, so of degree n, with our leading term not equal to 0, we see that if the degree is odd and a n is positive, the leading term coefficient is positive, then it will fall as x gets negative, and it will rise as x gets positive. This, by the way, is often called end behavior, because we're looking at what is the behavior of the graph at its different ends. Okay? So in other words, we expect our graph in general, we don't know what it does in between, but it should go down this way and up that way in the end. Similarly, if n is odd, but the coefficient is negative, the leading coefficient is negative, then it will rise as x gets negative and fall as x gets positive. Well, how can you sort of see that? The way you can see that is that this one, because your degree is the same, you can sort of think of this as a reflection across the x-axis of this. So again, the stereotypical thing here would be something like x cubed. Here, the stereotypical thing would be something like negative x cubed. Here, x even, this will look like something, and with positive x leading coefficient would be something like x squared. This would be something like negative x squared. And indeed, we see that these do in fact behave just like x squared and negative x squared. Namely, when n is even, our degree is even, but our leading coefficient is greater than 0, what we have is that it will rise to the left, rise to the right, and here, if we have a leading coefficient negative but still even degree, it'll fall to the left, fall to the right. So let's do some quick examples. Let's describe the right and left, the left and right hand behavior of the graph of each of these functions. For this one, we see that we have positive here. It's odd with an less than 0. Here we have that, well, let's go ahead and finish this one. That means the behavior would what? Well, that means that it should go up here and down here. We have a notation for that, though. What we really want to say here is that the function f of x goes to positive infinity. In other words, it gets large in the positive direction as x gets large in the negative direction. Similarly, we have that f of x goes to negative infinity as x goes to infinity. So let's go through, and as we do these others, we'll go ahead and see that as well. So, continuing in this, if we go down here, I'll show the actual graphs at the end. As f of x goes to, let's be honest, I'm not going to show the actual graphs. As x goes to here, what do we see? We see that f of x, x to the fourth minus 5x squared plus 4. What happens here? Well, we have that x, it's even, and this one is odd. And this one has an positive, and this one also has our leading coefficient is positive. Well, if it's even with positive coefficients, it should go up and up. Namely, we should have f of x goes to infinity as x goes to negative infinity, and as x goes to positive infinity, f of x should also go to positive infinity. Here, we expect with odd and positive leading coefficient down, up. So x goes to negative infinity, f of x goes to negative infinity as x goes to negative infinity, and x goes to positive infinity, f of x goes to infinity. And now it's time for you to try, so go ahead and determine the behavior and the notational behavior of these two functions. On the count of 3, I'll reveal the solution. 1, 2, 3. So here we see that because the leading coefficient is odd, that the degree is odd and the leading coefficient is positive, that f, our function, should get large in the negative direction as x gets large in the negative direction, and our function should get large in the positive direction as x gets large in the positive direction. Here, because we're basically flipping this, making our coefficient, our leading coefficient negative, we'll have the opposite. For more practice and working with end behavior, be sure to see pages 132 and 133 and work these problems from the textbook. In our next video, we'll talk about real zeros and their multiplicity for helping us graph polynomials.